Hello everyone, welcome to my new video in my Mathematics Essential series. In this video, I will start proving the trigonometric identities in this list of 19 trigonometric identities. Now, I said in a previous video that I will prove 3 of them geometrically, and from those 3, we can prove the rest by applying these 3 in conjunction with others that we prove along the way. Okay, so the 3 identities that I will prove geometrically are highlighted in green, and they are trigonometric identities 3, 10, and 11 from the list. So let's go ahead and give a geometric proof of trigonometric identity number 3. It's called the Pythagorean identity because it's really just an instance of Pythagoras' theorem in disguise, and that will be apparent in the proof. Okay, so let's start the proof. And consider a unit circle centered at the origin in the Cartesian plane and a right-angled triangle anywhere within the unit circle such that its hypotenuse is a line segment from the origin to some point on the circumference of the unit circle. Okay, this defines an angle theta measured counterclockwise from the positive x-axis, as is the convention. And let's call that point on the circumference P, which has a coordinate with x and y components. Now, since the hypotenuse of this triangle is the radius of the unit circle, and you know that the radius of the unit circle is 1 by definition, well then we also know that the hypotenuse of this triangle has a length of 1. And since the adjacent side to the angle theta is just the x component of the point P, the length of the adjacent side is just x. Similarly, since the opposite side to the angle theta is just the y component of the point P, the length of the opposite side to theta is just y. So we know all 3 side lengths of this right-angled triangle, and by Pythagoras' theorem, we know that the square of the hypotenuse is equal to the sum of the squares of the other 2 sides. Applying Pythagoras' theorem to our triangle, we get that 1 squared is equal to x squared plus y squared. But of course, 1 squared is just 1. So our equation becomes x squared plus y squared equals 1. Now recall that P could be any point of the circumference of the unit circle. Okay, I just picked an arbitrary place on the circumference to place the point P, but I really could have placed it anywhere. So this equation really allows you to solve for any x value and any y value of any point on the circumference of the unit circle. In other words, x squared plus y squared equals 1 is the equation for a unit circle centered at the origin. But by the unit circle definitions for cosine and sine, x is equal to the cosine of theta and y is equal to the sine of theta. Now, if we make these substitutions into the equation for the unit circle, we obtain the cosine of theta squared plus the sine of theta squared equals 1, which completes the proof because that's precisely what the Pythagorean identity says. So now we can go back up to our list and cross off trigonometric identity 3, which is the Pythagorean identity, and that's 1 down, which leaves 18 to go. In the next video, I'll give a geometric proof of trigonometric identities 10 and 11, and both of those identities will fall out of one proof. We don't need to do 2 separate proofs for each of the 2 identities. One proof, and we get 2 identities. And from what I've seen, these proofs are sometimes skipped in math classes, and that's a shame because the proof is rather elegant, and if you've seen a proof of them before, you may not have seen the one that I will provide in an upcoming video, the very next video actually. So if you enjoyed this video, give it a like or share. If you have any questions, just comment. And if you'd like a notification when I upload a new video, just subscribe to my channel. Until next time, bye for now.